Hey everyone, welcome to your second Play Posit of the week. It is March 11th now, hopefully when you're watching this, Thursday, March 11th. If not, you're watching this prior to our next class next Tuesday. And we're going to be covering 3.02 in your OMHS, so go ahead and grab your notes, have that Play Posit graded assignment open, and we'll get started. Two quick announcements. The first one, I believe I already mentioned to you guys in our Tuesday Play Posit, but we're super excited. A few of the math teachers have gotten together and created a super fun virtual assembly for you guys this Friday at 11 to help us celebrate Pi Day. So there are more details in the middle school newsletter for you, but even if you don't bring anything or you don't read the newsletter, you can just pop in and see what kind of fun is happening. To go along with that, we are sort of facilitating the tracking of a Pi Day virtual fun run, if you will. So just to help ease anyone's fears who doesn't like to run, you don't have to run. It could be any sort of activity that you do for 3.14 miles. Some examples here are running, walking, biking, anything to support mathematics and your health. Swimming, playing soccer for 3 hours and 14 minutes. That's a long time. But you get the idea. And I will provide, there's a Google form link that you guys can track your progress in, that we help celebrate all of your accomplishments in the celebration of health and mathematics. All right, so here's our flashback of the day. This is a question that I pulled from TestNav. So some of you may have been checking out the SOL resources, and TestNav is an awesome platform. It's basically a SOL simulator. It looks exactly like what you'll see on test day, and it has a bank of practice questions. So I pulled this one from there. So we're going to reduce the cube root of 3,456. That's a honker of a number. That's a big number. So don't forget that you guys can definitely grab your calculator and let's reduce this. I'm going to actually see if I can move my flashlight over, give myself some space. There we go. So we're just going to factor tree this number out. We're going to break it down. And you can, like I said, you can use your calculator to help you do this. I usually kind of just start with 2 and see how many times does 2 go into this huge number. And when you grab your calculator, you'll see that it goes in 1,728 times. That's a lot. We can just keep trying 2 until 2 doesn't work anymore. So 2 goes into that 864 times. Don't forget, I know I always say this, but if for some reason I did not put a pause in the video for you, you guys can always pause it yourself. Try the question and then come back for the answer, always. So then 864 is 432. We just keep going. 2 is definitely a factor of 432 because all these 2's at the end. So that's 216. And 216 is 108. And half of 108 is 54. Half of 54 is 27. Okay, now we get to 27. We know 2 is not, or 27 is not divisible by 2. So then I just go to the next number. Let's try 3. The next prime number. And we know that that is 9. And then 9 is 3 times 3. So finally, we have reduced it down to all of these prime factors. There's 1, 2, 3, 4, 5, 6, 7 2's, 3, 4, 5, 6, 7, and 3 3's. So we are doing the cube root. So if you guys recall, that means we're looking for groups of 3. So we have a group of 3 2's, another group of 3 2's, and a group of 3 3's. So there's kind of 2 ways to think about this. We talked about how once you find it, you take it out, right? So we can take a 2 out, take a 2 out, and take a 3 out. The other way, sort of the more mathematical way to think about this is, look, 2 times 2 times 2, that's 8. That's 8. And this is 27, right? So what we're really looking at is what is the cube root of 8? The cube root of 8 is 2. The cube root of this 8 is 2. The cube root of 27 is 3. So it's just kind of another way to think about it. And then we'll just write what's left underneath that radical that didn't find a pair or a cubed pair, and that's just the 2. So I mean, we're pretty much done. Let's just simplify this. So 2 times 2 is 4, and 4 times 3 is 12. Cube root of 2. So we have reduced this huge number to something much simpler, and the answer is C. So there is another way to do this problem, and maybe some of you have tried it. You can kind of use your calculator. You could put this into your calculator and get a decimal, right? And then you could put all of these into your calculator and get a decimal and see which one matches. The only thing I would caution you about is it wants it in simplest form. So some of these might match, and you're like, wait a minute, there's more than one answer. That just means it's not in simplest form. Like if you look at 16, that could be broken down further, right? Into 2 times 2 times 2 times 2. So there's another 2 that could come out of that. So while sometimes you might say, oh, well, there's more than one answer, it wants the simplest form. So just keep your eye on that. Always, one of the best test-taking tips is to read the instructions super carefully and read them more than once. Okay, this is my favorite slide, I think, of the whole year. Like, I look forward to it, and I should share it more often. But hopefully by now, you have realized and learned, I mean, I'm hoping that I have instilled this in you, that there is more than one way to get a right answer. We have multiple tools for most everything we do in class. And I believe that that is at the heart of problem solving. When you have those tools and you're presented with a problem, you get to choose. You get to work through the problem and the solution based on all the tools that you have. You're not being graded or told one certain way to do it. That's my hope. I know that sometimes, depending on the way the test question is written or depending on the quiz that you're doing, you might have to show a certain method. And I get that. Sometimes we do have to do that, right? Just to kind of show that we're learning all those tools, keeping those tools sharpened, if you will. But I love this meme, and I love her smile because it's like, hey, she's being so sarcastic. Well, that's the point anyways. All of your answers are right, but you didn't do it the hard way. 0 points. And this is me. Ha, ha, ha. Yeah, right, lady. Never, never, never. Okay, so you can do it the easy way. You can do it the hard way. You can do it the middle way. That's the beauty of having all those tools to get to the same answer, is that you guys get to choose. And sometimes the way our brains work, they're all different, right? Is that you're more comfortable with a certain method, or maybe you see a certain method first and you're like, I'm going to go with that. And that's how it should be. So I laugh at this lady. I'm sure she's very nice in real life. I just don't agree with what she's saying. And I want to continue to share that with you guys because I want to continue to encourage you to, yes, learn and understand all of the different methods, but also realize that you have choice. And that's really, again, that's the whole purpose of problem solving in everything we do in life, right? So today we're going to continue with quadratic equations. That's kind of why I love Unit 2 and 3 in Semester 2, because they go hand in hand. We just kind of slide right into Unit 3, and hopefully it doesn't feel like anything new, sort of just an extension. So we're going to do some more solving. We're going to see something called the quadratic formula today. And then we're going to talk about the number of solutions. So there's a test we can do to help us determine the number of solutions that a quadratic will have. So that's what we're going to do during this play pause it. So here we go. We're going to solve the following quadratic equation. And again, this is just an extension from everything we've been doing. So it's always a good idea to get everything on the same side. So let's move the 14 over. We're going to have m squared minus 5m minus 14 equals 0. So we're trying to solve for m in this case. Excuse me. So I know I've said this before. I'll say it over and over, is that there are multiple ways to factor. I'm going to factor using the Ma chart because it's my favorite, because it works and it's systematic. I'm a systematic kind of person sometimes, but if you like the guess and check, go ahead and do it. If you like slide and divide, go ahead and do it. So the first times the last is negative 14m squared. And we're trying to find two numbers that multiply together to give us this and add to give us the middle term, negative 5m. So the first step is to just list the factors of negative 14m squared. What times what gives us that? And there's a few, right? There's always 1 and itself. And since it's negative, remember, either one could be negative. So you kind of have to take into both accounts. And then there's the 2. I'm kind of going systematically. Like I start with 1. Does 1 go into it? Always. And then try 2. Negative 2 and 7, right? That gives you negative 14m squared. Or maybe the 7 is negative. And that's it. Those 4 pairs of factors. Those 4 factors. Which one of these pairs adds up to negative 5? Oops, this should be 2. There we go. It's that one. Negative 7m plus 2m is negative 5m. So we found it. Now that we found the special pair of numbers, we're going to replace the middle term. Now remember, we're not changing the value of the quadratic at all. We're just changing the way it looks. So instead of negative 5, we wrote negative 7m times 2. It's kind of like we're trying to trick it to be something it's not, so we can solve it. So now we're going to group the first 2 and group the second 2. So we're trying to look in the first 2 here and see, what do they share? What is the GCF that we can take out, that we can factor out? And they both share an m. So we'll take an m and put it on the outside. And we have left m minus 7. The second pairing here, you guys can always do the cake method, right, to find that GCF. I have a feeling a lot of you are kind of getting maybe more comfortable and quicker finding the GCFs in your head. But here, let's do the cake method over here real quickly. So to find the GCF of these 2 terms, I'll put a 2 on the outside. Again, it's always good to start with 2. And so 2 goes into 2 once, and 2 into 14 7 times. And this is a very small cake, a 2-layer cake, because we stop at the 1, right? Whenever you get to prime numbers, you're kind of done, because there's nothing else that you could divide into those besides 1. So the GCF is 2. So we have left m minus 7, right? Because we're basically, what you're doing is taking each of these terms and dividing that GCF. So negative 14 divided by 2 is negative 7. Now here's that step we've talked about. Let me grab my highlighter because it's fun. Look, these match. So now we can go ahead and write our final answer as the 2 GCFs together and one of those factors. Now I just have to solve each of these for m. 2 little mini solving problems. M is negative 2 and m is 7. So don't forget that we can totally graph this and see if our solutions make sense. Another way to write this would be using our curly brackets as a list of numbers. You might see solutions like that. So let's go to Desmos and graph it. Don't forget, we learned last time that we do need to use x's because Desmos has the horizontal axis right now as x and the vertical axis as y. That minus 14. All right, there they are, -2 and 7. Yay, they match. Perfect. That was a nice review of factoring. Let's keep solving. Solve the quadratic equation. So again, let's get everything on the same side. Let's see. All right, sorry about that, you guys. My pen literally like disappeared. I don't know if you saw the gray up in the corner, but it appears to be fine now. So we're gonna get everything on the left-hand side. We're gonna add the 10. So you'll end up, instead of -13, we're gonna have -3. So we're just rearranging this a little bit to get everything on the left-hand side. All right, so when you look at this, there's no GCF that you can take out of all of them. So we're gonna go ahead and try our MA chart. So we're looking for a number that multiplies the first times the last. So that's -6m squared. And it has to add up to give us the middle term, -7m. So let's start listing the factors of -6. It could be -1 and 6, right? That'll give us -6. Could be -6 and 1. Could be, then I'll go to 2, right? We did the 1. How about -2 times 3 and -3 times 2? So those are all the pairs of numbers that would multiply together to give us that -6m squared. Do any of these add up to -7? Hopefully you're like, well, maybe, but no, right? Because -1 plus 6, that's 5. It looks promising, but it's not quite working out, right? -6 plus 1, that's -5. So no, there are no pairs of numbers that add up to give us the middle term. But do not fret, you can still do this. And when you can't factor something traditionally, using the MA chart, using slide and divide, using guess and check, we have something else that we can use to help us factor or solve, really. And it's called the quadratic formula. Here it is. And just take a deep breath, because I'm going to tell you right away, the great news is that this is on your formula sheet. You may have seen it. I snipped this right from your formula sheet. So that means you do not have to memorize it. Students usually love to hear that. I will say that you likely will because you're just going to be using it so frequently and you're going to be writing a lot as you're practicing. So it's going to start to feel like second nature, but you do not have to memorize it. The one thing that I wanted to point out is it tells you that A cannot be 0. There's kind of a few reasons for that. If you look here, A is in the denominator. And if A were 0, you can't divide by 0. That's undefined, right? So we're not allowed to divide by 0. Also, if you think about the quadratics that we have, if A were 0, that term would go away. So you would just have bx plus c, right? Is this a quadratic? No, that's just a line. This is linear. So that's why A cannot be 0. If A were 0, you would just solve it a different way. You would just solve for x. It'd be easy. We also want to recall standard form. Remember, standard form is sort of the traditional way that you would write a quadratic in descending order of those exponent values. So squared, 1, and then no variable. So it does have to be in standard form for us to plug it into the formula properly. So don't let it scare you. Let's get started. This is the same exact one, the one that we decided we could not factor traditionally. So we're going to use that quadratic formula. And you guys have it in your notes, but I'm just going to write it here. All over 2a. Okay, so step 1 is still to get everything on the same side. So we have 2m squared minus 7m minus 3 equals 0. And then I like to list out my coefficients, if you will. So A is the coefficient with the leading term here, so that's 2. B is the coefficient of the second term, and C is the constant, -3. Just goes in order alphabetically, A, B, C. That's nice. So now we just plug them in. So negative B. So be careful, it's a negative and then whatever B is. B is -7. Plus or minus the square root of B squared. That's a -7. Minus 4 times A times C. All over 2A. So think back to PEMDAS and the order of operations. We're going to do what's under the radical first. I mean, you can go ahead and simplify this. Negative times a negative is a +7. And then under the radical, -7 squared is 49. 4 times 2 times -3. -4 times 2 times -3. That's +24. All over, whoops, I forgot to put A in. So this should be 2 times 2, which is 4. All right, let's keep going. So we're going to have 7 plus or minus 49 plus 24, 9, 73. Okay, and I mean, we're kind of done. It looks funky, but there are two solutions here. There's the positive and there's the minus. So you might also see it written like this, where you have plus root 73 over 4 and the minus root 73 over 4. And that's it. You could technically write it as a decimal, but you're not going to see it written as a decimal as an answer choice. But you could go ahead and get the decimal if you wanted to and then check it in the calculator, right? You could still plug in this original quadratic, see where it crosses, and it will cross at those decimal values. So you can always still check your work. But they're going to want you to leave it. This is the most simplified form because whenever you have a decimal, you usually have to round. And so you're losing some of those values. So this is it. Oops, I know it looks a little funny, but that's it. I will caution you guys that you definitely want to double check that you can't reduce in what is under the radical like we did in that SOL flashback, that warm up that we did, because if you can reduce that, you need to. And you're going to see some today where we do that. All right, let's do it again. So look, everything's already on the same side. So we're going to go ahead and see if we can use the MA chart. So first times the last is 9x squared, and the middle term is 8x. So 1 times 9 and 3 times 3. And of course you could do the negatives of either of these, right? Because a negative times a negative is positive. Sadly, none of these add up to a positive 8x. But don't worry, you can still do it. We just need to use the quadratic formula. So this is nice. This is already in standard form. So A is 1, B is 8, and C is 9. So we're just going to plug it in. Let me write it up here again. You have it on your paper, especially if you guys printed the guided notes. All right, here we go. -8, I'm just plugging it in, following along. 8 squared minus 4 times 1 times 9. I will say that because there's a lot of replacement here, there are many chances for mistakes, so just be careful. There we go. All right, so now we're going to simplify. 8 squared is 64. -4 times 1 times 9 is -36 all over 2. 64 minus 36 is 28. And I mean, that's it. You're done, except double check. Now 28, that looks like it can probably be reduced, right? So let's reduce, it's kind of its own separate little problem. We're going to reduce the square root of 28. Oh no, I wrote it again. So 28 is 2 times 14? Yeah. And 14 is 2 times 7. So we really have 2 times 2 times 7. So since this is square root, we're looking for pairs of numbers. Here it is. Take it out, because that's really 4, right? 2 times 2 is 4. So the square root of 4 is 2. Take it out. There. Root 28 is the same as 2 root 7. So instead of root 28, I'm going to write 2 root 7. Okay. Now, when you look at this, because all 3 terms share a factor, you're allowed to reduce it. This is a term, this is a term, and this is a term. All 3 of those share a factor. Do you guys know what it is? What can they all be divided by evenly? Remember, this is just 2 times root 7. So we can actually reduce all 3 of these by a 2. So essentially you're doing this divided by 2, this divided by 2, this divided by 2. So negative 8 divided by 2 is negative 4. This gets rid of that 2 in the front, and you just have root 7, and you get a 1 on the bottom. So all of that reduces down to negative 4 plus root 7 and negative 4 minus root 7. Those are 2 solutions. Don't forget, you could definitely get a decimal for each of those and then see, let's do that. Let's do that once. So negative 4 plus root 7. Where's my root? I'm laughing because there's something coming up with roots. Okay, so we're going to have that as one solution. And then you're also going to have negative 4 plus root 7. And that'll be your second solution. So wait, plus and minus. Here. There we go. So negative 6.64 and negative 1.35. So let's put in the original quadratic and see if those really are where the line crosses the x-axis. So I wrote down here because you guys know me, I always forget when I'm going back and forth between the PowerPoint and Desmos. 8x plus 9. Look what that did. Okay, there we go. All right, so let's go click on those spots where it's crossing the x-axis, and they should match the solutions we found. I don't know why I'm always so excited. See? And you guys can celebrate at your desks. You can hoot and holler, and your learning coach can be like, what are you doing? And you say, I'm doing math. I think that's super cool. Awesome way to just confirm your work. All of your hard work is confirmed. The click of a button. All right, so sometimes in math, we have things that are special and we name them. We meaning like the old ancient Greek mathematicians. So the value that's under the radical bar has a special name. It's called the discriminant. The discriminant. And the discriminant describes the number of solutions there are in a quadratic. So it's actually super helpful. So this is in your notes, and I don't want you to feel like I put it in your notes because I didn't want you to have to write everything. I'd rather you guys listen and make some little notations as we go along. So Remember, the discriminant is just the part under the radical of the quadratic formula. So just this part here, which is written here. And guess what? They label it with a big D. Isn't that nice when the labels actually make sense? Like, why didn't they call slope S? Slope is M. Sometimes it just, like, who are they? Why did they do that? But they, this time, chose big D to represent the discriminant. So it's kind of like a test. When we plug in the values for B, A, and C, if the discriminant is less than 0, so if it's negative, that means the graph does not cross the x-axis at all. See? Meaning there will be no solutions, no roots, no zeros. Remember, those are all words for the same thing. Solutions, roots, and zeros. Because that's the definition of a zero, is when y equals 0. That's what it means to cross the x-axis. If the discriminant is 0, that means it's right on the x-axis just one time. And if it's greater than 0, that means you get 2. We've seen a lot of those, right, where the graph is crossing the x-axis in 2 places. So you either have no real roots, one real root, and 2 distinct. I say distinct because sometimes when you have one real root, you kind of have 2, and I'll show you, but they're the same, so that's really just 1. You'll see. So here we're going to do the test. What type of roots does this quadratic have? And then let's find them. So remember, the test is just the discriminant, which is what was under the radical, so just this part. So you still want to get it in standard form so we can pull off the A is 1, B is 4, and C is -5. You still need those 3 important values. Then we'll plug them in. So we have 4 squared minus 4 times 1 times -5. And then we can just do that math, right? 4 squared is 16. -4 times -5 is plus 20, positive 20. And then these add up together to give us 36. So 36 is greater than 0, much greater than 0. So that chart tells us that there are 2 distinct roots. 2 distinct real roots. You know, you could also just graph this and take a peek at the graph. What does it look like? And if it's crossing that x-axis twice, then you know the discriminant is going to be bigger than 0. And you know there are 2 real roots. So they kind of go hand in hand, the visual and the algebraic. So it says to find them. Well, you may have seen by now or maybe realized that you can use the quadratic formula every single time if you really wanted to. Maybe you don't want to use the mod chart. So even if the mod chart works, you don't have to use it. You can use the quadratic formula on everything if you wanted to. Just saying. Or you could use the mod chart. So it's kind of up to you guys. If we were in live class, I would take a poll. So since we are kind of starting to learn quadratic, let's do the quadratic formula on this one. Plus, we already have the value under the radical. So remember, the quadratic formula is this. So let's plug in, I'm going to get a different color. So B is 4. We already know this, the discriminant, is 36. I'm just going to put that in there. And over 2. All right. The square root of 36, that's 6. That's beautiful. Now we have to sort of separate it to get our 2 answers, right? So this is going to be -4 plus 6 over 2 and -4 minus 6 over 2. Remember that plus and minus in the middle gives you those two different answers. So this is 2 over 2 and -10 over 2. Oops, that should be a minus or a comma. So really, sorry, hold on. Really, you have 1 comma negative 5. If you guys chose to factor using the Ma chart and it worked, it will work in this case, you would get the same exact answers. I'm laughing at my meme here. And a lot of you are probably yelling, going, that's not a square. Yeah, I know, but it looks like the radical bar has a square root. And it's the root of a tree, so rectangular root. Okay, just a reminder, you can put this in the graphing calculator and confirm your solutions. So I know that I told you guys last time that you can't really use the calculator to factor, and that's still true. You can use the calculator to find solutions and to help you factor, but you'll never be, well, you can't always use it to get these. You know, like if the problem says factor and they want you to get the 2 factors, just like this. Sometimes you can use the calculator, sometimes you can't. So I'm just going to keep warning you about that. Caution. So if we were to write this in factored form, we could use these solutions, right? Remember, the factored form is the opposite of the solution. So it would be x minus 1 and x plus 5. Because if you were to solve each of those, you would get x equals 1 and x equals negative 5. So you kind of work backwards. That's how you can use the calculator to help you factor sometimes. All right, what type of roots does this have? And let's find them. So what type? That's our test. B squared minus 4ac. So a is 1, b is 2, c is 1. So 2 squared minus 4 times 1 times 1. 4 minus 4 is 0. So what happens when you get 0? That means it crosses the x-axis 1 time. There's 1 real root. So let's see what it is. This time I'm going to try the Ma chart. Because it says there's a, because it says there's a real root, then we know that the Ma chart's going to work. Okay, so r squared times 1 and 2r, the middle term. So the factors of 1 are just 1 and 1. And thankfully, easily enough, 1 plus 1 gives us the 2. So we are going to replace the middle term with the 2 numbers we found, 1r plus 1r. And now we're going to factor by grouping. So we're going to group the first 2 and group the second 2. And we're going to treat these as 2 little tiny factoring problems. So when you look at the first 2, what do they share? What can you take out? And it's an r. So you have r plus 1 left. And the second 2, what do they share? They don't share anything, right? So when they don't share anything, you can always take out a 1. And we'd have r plus 1. So these match, which means we did it correctly. So we can write r plus 1 and r plus 1. So we'll set each of these equal to 0. And see how you do get 2 solutions, but they're the same? So there's really only one solution. R equals negative 1. That's where it's going to cross the x-axis. Let's see. Remember to put in x's. Don't do what I did the last time and put r's and be like, what? That was fun figuring out that together with you guys. So let's see. Oops. There. X squared plus 2x plus 1. There it is. It hits the graph just one time on the x-axis at negative 1. Perfect. All right, thanks for hanging in there with me. I know that this is a longer play posit than usual. And I think, we have 2 more examples. They're both very similar. So what I'm actually going to do is give you the answer, and I want you guys to work them out. So this one, and we'll go over these together the next time we see each other in live class. So when you factor this or use the quadratic formula, this or these are the solutions that you'll get. Again, remember, you can also see it written this way as two solutions. So depending on how the question has it worded. And then the last one, the solution is 4. Because I have so much fun doing this. Look, I like work it all out. So fun. So again, thanks for sticking in there with me. Coming soon, I know that we did not have classes last week due to the SOL writing test, and I hope that you guys all did your very best. I'm sure you did great, all the 8th graders. And then we had our snow day, another amazing accomplishment by you guys. So if I don't see you in class on Thursday, I'm excited to see you guys next Tuesday in live class. Please don't hesitate to reach out with any questions via email or attending those extra help sessions with Miss Jadala. Bye, everybody.